Hello and welcome to the first lesson of our second unit, quadratic functions. This unit is going to go over various types of functions, including polynomials. We're going to begin with basic quadratic functions. The definition of a quadratic function, a, b, and c being real numbers and a not being equal to 0, is any function given by an x squared being the highest variable. Once again, it's important a would not be a 0 there, but it could be any other number. If you have an x squared graph, it's a parabola known as a quadratic function. Our first example asks us to sketch some basic graphs of quadratic functions. Now, this should already be somewhat familiar to you from 1-4 we discussed transformations. Notice my y equals x squared graph is going to go like this and like this, very basically. The number that is in front of the x squared is either going to compress or enlarge or widen the quadratic function. So having y equals 1/3 x squared, it would be 3 times wider. With y having 2x squared, it would be twice as narrow. Keep in mind that here, if you were to evaluate it for 1, up at the top equation, y equals x squared, when x is 1, y is 1. Over here on the left one, when x is 1, y is 1/3. On the last one, when x is 1, y is 2. So you kind of see it goes twice as fast on the bottom one, but on the second one, it goes about 1/3 as fast. In other words, that's how fast it progresses. So this a value that's in front is going to really determine the intensity of how much it sweeps up, how narrow, how wide it is. The standard form of a quadratic equation, so before we had the general form, this is the standard form, and this would also be called the vertex form. That's the way I learned it when I was in school, was the vertex form, because you can take what it gives you in the middle parts, and you can use that to find your vertex. So if I have this right here and this right here, my vertex is at h comma k. So in other words, it'll be the opposite of whatever the h number is, and k will be the y value. And it says that right in here, the vertex is the point. So if I have this function, the graph of the f is a parabola whose axis is a vertical line x equals h, and whose vertex is the point h comma k. When it says axis, that means the axis of symmetry. Runs right through the vertex. If a is greater than 0, the parabola opens upward. If a is less than 0, it opens down. In other words, this means if a is positive, it opens upward, and if a is negative, it opens downward. So sketch the graph of 2x squared plus 8x plus 7. Identify the vertex and the axis of the parabola. Now, you could do completing the square here, which is just always so much fun, or there's a trick to finding the vertex. There's a trick to finding the vertex, okay, called finding the discriminant. The discriminant is the opposite of b over 2a. Alright, and we're finding the axis, of course, of symmetry of the parabola. The discriminant is going to be the x value of the quadratic for the vertex. This will give us our h. So if I label these a, b, and c, I can very simply type in negative 8 over 2 times 2. The 8 was b, and it's the opposite of b over 2a. So that's negative 8 over 2 times 2, which is 4, which then gives me negative 2. So my vertex has negative 2 comma some y number. To find that, I'm going to plug it back in. 2 times negative 2 squared plus 8 times negative 2 plus 7. Excuse me, 2 times 4 plus negative 16 plus 7. 8 plus 7 minus 16, 15 minus 16, which equals negative 1. So the vertex of my parabola is at negative 2, negative 1. Again, I found that by doing the opposite of b over 2a for the x value of the vertex and plugging that back in once I got a number back into the original equation. If I were to rewrite this in standard form, it would look like so. Well, I'm not going to rewrite it in standard form. Let's just graph it. I'm just sketching a graph. I'm going to go to negative 2. I'm going to go down 1. This c value is also the y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I know I'm going to have a point there. So my graph goes like so. And like so. The axis of symmetry is that x equals negative 2. Your axis of symmetry of a parabola is always going to be x equals, and it'll be the x value of your vertex. That's why finding the discriminant is so key. That little trick to finding the discriminant is so absolutely important, because when you take the opposite of b over 2a, you found your axis. You've also found your x-coordinate for your vertex. It makes it very easy to start sketching the graph. Okay? So find the vertex and the x-intercepts of the parabola. Now in this case, I'm going to look at it and I'm going to see if it factors easily. So if I take something out of this, let's factor out the negative first. So now I ask myself, can I unfoil this such as I have two numbers that multiply to be 8 and add to be 6. They're going to be the same. This tells us right here this number tells us right here that they will be the same. And this tells us that they'll both be negative. So I'm going to unfoil these. So negative and negative. Well, if I make a chart of what works for 8, it goes 1 and 8, 2 and 4. Do any of those add to be 6? 2 and 4 do. So my x-intercepts will be x equals 2 and x equals 4. Okay, that works quite nicely. So that tells me my x-intercepts are x equals 2 and x equals 4. To find the vertex, let's do the discriminant. So opposite of b over 2a for the x value, which will give me negative 6 over 2 times negative 1, which gives me positive 3. Okay? So now when I plug positive 3 back in, I'll get negative 3 squared plus 6 times 3 minus 8. Negative 9 plus 18 minus 8. Add those up, and I get 1 as my answer. So the vertex will be 3, 1. The axis will be x equals 3. So if I go to my graph, I know this sign tells me it points down. This tells me my y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. My x-intercepts are at 2 and 4. And it told me I have a vertex of 3, 1. Well, now I've got a couple of points that makes it kind of easy to sketch. And there's my graph. So I had a vertex of 3, 1, an axis of x equals 3, and it kind of made sense that the vertex would be halfway in between, because it's symmetrical, would be halfway in between the two x-intercepts. So I just start making a list, basically, of what do I have. What do I have? What do I need? Well, I have the y-intercept. I can plot that. I was able to find the x-intercepts by simple factoring. Perfect. If not, we can use the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac over 2a. And use that for the x-intercepts. That works as well. The discriminant to find the vertex. So I start piecing those together, and immediately I have 4 points, and that gives me a nice little sketch. Now, graphing it and sketching the graph are two different things. Sketching a graph means give me a rough estimate. Give me a general idea that you know what it looks like. Graphing it requires detail, and we're going to want at least 3 or 5 points, typically 5 points for a parabola. So write the equation of the parabola whose vertex is 1, 2, and it passes through the point 3, negative 6. So my equation in standard form was A equals, let's go back to the last page and look at it, y equals A times x minus h squared plus k. So A times x minus h squared plus k. What they've given me here, they've given me the vertex, that's my h and that's my k, and they've given me an x and a y point. Now we're going to use the same logic from chapter 1 where we plugged in points into a line, into the standard form of the equation of a line, and then solved it to find the y-intercept. We're going to use the same process here. So I know I'm going to have that y equals a times x minus 1 squared plus 2. Now, at first glance you might say, well, we're done. Well, we're not quite done yet. What I have to do is I have to plug in 3 and negative 6 to solve for a. So I'm going to say negative 6 equals a times 3 minus 1 squared plus 2. All right? Let's go ahead and take care of what's in the parentheses. 2 squared plus 2. A times 4 plus 2. Let's subtract 2 from both sides. And divide by 4. And A equals negative 2. So now my final equation of the line, of the parabola, rather, is y equals negative 2 times x minus 1 squared plus 2. Now you'll notice up at the top, I did every individual operation step by step. 3 minus 1 to 2 rather than combining steps. I prefer you don't combine your steps because it makes it easier for you to see your work in a flow format and for me to see your work and to know how it's going. See where you make mistakes at. So that's why I did 3 minus 1, then 2, then 4, then subtract 2, even though obviously we could have combined those steps in several places. But it's a good idea to keep yourself flowing in the right direction. So the minimum and maximum values, will exist at the vertex. This is a fancy definition. It says consider the function blah 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 with the vertex opposite of b over 2a, and then basically that means f of opposite of b over 2a, meaning you plug it in. That's your x and your y. The key thing is the minimum / maximum occurs at the vertex. So if you plug it in and you find the vertex of your parabola, you will find the minimum or the maximum value of the parabola. Now, minimum and maximum values have some key applications. The first one we're going to see here in this example is the maximum height of a baseball. So they give you the equation. So the baseball is hit 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path is given by the function f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance. What is the maximum height reached by the baseball? Maximum height is going to end up being the y value of the vertex. So what I have to do is I have to find the vertex, and once I find the vertex, I plug that back in, and I'm good to go. So I'm going to take opposite of b over 2a. So this is my a, this is my b, that's a 1, and that's my c. So negative 1 over 2 times negative 0.0032. Okay? For this occasion, it's not a bad idea to use a calculator. As much as I hate them, they do serve a purpose. So I'm going to take, my negatives will cancel out, so I'm going to take 1 and divide it by, and then put in parentheses 2 times 0.0032, and then close parentheses, and I get 156.25. I believe that's what that was, yes. So I took negative 1 divided by 2 times negative 0.0032. The negatives cancel out. 2 times 0.0032 is 0.0064. 1 divided by that is 156.25. That is the horizontal distance at which it reaches its maximum. So if it's 100 feet per second and the baseball is hit, baseballs go pretty fast, pretty far. I learned this the hard way once when I was pitching a baseball game in middle school, and I pitched the baseball and they hit it and it came at me and I cried a lot because it really hurt, and they lied when they said it wouldn't hurt that much if you got hit. The coaches really, really lied. So consider how fast and how far a baseball goes. If you hit a baseball hard, 156 feet away from home plate is not that hard to see it reaching its maximum height. That tells you that it's going to go for about 300 feet. So the middle of it is 156.25. So now what I'm going to have to do is I'm going to plug in f of 156.25 into my equation. So I'll get negative 0.0032 times 156.25 squared plus 156.25 plus 3. Okay? So now I'm going to do a much more lengthy calculation. So I'm going to take 156.25 and I'm going to square it, and I'm going to multiply it by negative 0.0032. Let me do that again to make sure I did my math right. Square it times 0.0032. Yep, 78.125. Make that negative. Then I'm going to add it to 156.25 and then add it to 3. So then my answer is 81.125. So the maximum height of my baseball is 81.125 feet in the air. And that is my maximum. One of the greatest things that you can learn to do for graphing parabolas and dealing with quadratics is to learn the opposite of b over 2a rule. If you learn that and you learn that use that to find the x, then plug in the x to find the y, you have instantly found your vertex and you can start sketching any graph. The reason why that's so beneficial is because when you find that, then you start looking at the x coordinates, 1 to the left, 1 to the right, then 2 to the left, 2 to the right. And that allows you to start plotting points, and you can sketch any parabola instantly that way, and it works very well. But it also works then when you have to do the minimum and the maximum. Now in this case, what you had, if I were to graph it, you have a height of 81.25. It starts here at time index 0. Okay? It starts 3 feet off the ground. And it goes a distance of 156 times 2 is 312.5 feet. So what your baseball does is it basically goes same amount like this, and then after that continues to hit. Okay, that's what your baseball does. The maximum that it hits here, the max, is at 156.25 feet. After it leaves home plate, it reaches a height of 81.25 feet. The cool thing about this is, if you watch football, if you watch basketball, if you watch baseball, congratulations, you're basically watching parabolas. For those of you who hate math, your sport wouldn't be possible without our math. So, nanner, nanner, boo-boo. You watch shot put in track, you're watching math. If you watch someone jump a hurdle, you're watching a parabola. Pretty much all of your sport, except for hockey, for the most part, you're watching parabolas. Basketball, shooting a basketball. It goes up, it comes down. Congratulations, you have a parabola. You throw a football in the air and hope the other team doesn't intercept it. The other day I was watching a college game and a team upset another one by a Hail Mary pass right at the end. Boom. Congratulations, your Hail Mary pass. Every pass that is of a football that's thrown is a parabola. Your baseball that's hit, parabola. Your baseball that pitched, it's technically a parabola because no baseball goes in a perfectly straight line. So no matter what you're doing, golf even is a parabola. You hit the golf ball, it goes up, it comes down. Tiger Woods, all day, he's making his millions of bucks with parabolas. Your welcome world of sports provided to you by mathematics. Eat that. Everybody's a nerd. So if you're really a sports person, congratulations, you're a nerd. We win. That concludes today's lessons on parabolas and quadratics. I kind of apologize for the rant, but not really.